Hello, this is Nas from NB Network Lessons. Hope you guys are doing okay. My today's topic is circuit analysis, lesson 20, op amp, which is known as Operational Amplifier, part 1. This topic is going to be covered under several parts, so please make sure that you watch each part. In this way, we can build a foundation. Now, in summary, what I would like to tell you is that op amp basically does two things. Number one, it's used as a comparator. Number two, it's used as an amplifier. When I say comparator, it can compare two voltages, okay? It can compare 3 voltages, 4 voltages. So, and then there are a lot of other things also. In comparison can be difference in voltages, average in voltages, division, multiplication, multiply them by a gain, derivative, integral also. So all of these functions can be performed by op amp. And then secondly, amplifier, they take a small signal and provide you a signal with larger magnitude. So, but before we dive into it, I think it might be a good idea to look at some history, the foundation of op amp, okay? So before the evolution of digital computers, when we used to have analog computers, consider this. I have 3 race cars. Race car 1 is going at 50 miles per hour. Race car 2 is going 70 miles per hour. Race car 3 is going 100 miles per hour. All right? So what we do is that we have sensors in the field, okay? These sensors can sense and see what's the speed of the car. So the first one, we have a sensor and it senses 50 miles per hour, and then it relates or kind of like translates 50 miles per hour into 0.5 volt. Race car number 2, driving at 70 miles per hour. What we do is that the sensor picks it up and delivers it to the circuit, and circuit basically says, okay, I'm going to build a relationship, and it converts that to 0.7 volt. Race car 3, driving at 100 miles per hour. It's sent to the circuit, and basically the circuit translates that into 1 volt, okay? So now the input of all of these 3, 50, 70, 100 miles per hour is in form of 0.5, 0.7, and 1 volt. And at the output, we have programmed the circuit in such a way that it will present you with an average. So 0.733 volt, which we can easily relate to 73.3 miles per hour. Okay, so that's one example of comparator. Another example. So analog computer that calculates difference between 2 signals. So I have 2 voltages, obviously I have 2 signals, 2 sine waves. And what we need is, we need at the output, what's the difference, all right? So 3 volts, 5 volts, and V out is gonna be, this thing is programmed to calculate the difference of voltages. So it'll give you 5 minus 3 is equal to 2 volt. Like I mentioned, there are a lot of functions which op amps can do. This is just one. I'm gonna show you more functions later on in my lecture. So stay tuned, and I will see you in my next lecture. Thank you.